Well, good morning, everyone. I'm really pleased to be here with you today. I know people sometimes say that sort of thing just as a way of being polite, but I sincerely am extremely grateful to be here with you, and it's a real pleasure to be here with you at the 2018 European Lisp Symposium. So my official name, like you can see up there, is R. Matthew Emerson, but in real life, you can call me Matt or Matthew. I just use that for branding purposes. Just as a little bit about me so you can decide whether I'm worth listening to or whether my opinions are worth anything. I have worked on the Lisp implementation Clozure CL, and it was called OpenMCL before that, since about 2007. I used to be an employee of Clozure Associates, but now I work on it independently. And I was just thinking the other day when was my first exposure to Common Lisp, and I think it must have been on the Next machine using the bundled Allegro CL with that, way back in the day. So that's just sort of an interesting little side note. So the title of my talk is This Old Lisp, and usually when you have to explain your joke, it's sort of a sign that the joke isn't too good. So maybe my joke isn't too good here, so I'll explain it to you. There's an American TV show that's been around for a pretty long time called This Old House. And the point of This Old House is it was this home improvement show, right? So what they would do is they would show how you would fix a boiler or, fix an old style wall in an old house. And you have to understand also that, in the United States, if something's 100 years old, right, that's really old. And if something's 150 years old, why, it practically belongs in a museum. But anyway, the deal with This Old House was that the show recognized that a lot of people liked these old houses because the old houses were good. They were sometimes constructed using techniques that we wouldn't use today to construct a house. For instance, the way they would make walls would be different, or the way they would wire it up would be different, or maybe the way they would install heating would be different. But the house was fundamentally good. It had good bones. And so my thought was, well, Lisp is kind of like that, I think, and Clozure CL is kind of like that. It's something that is a little strange, maybe from the perspective of somebody coming into computing today. Some of the choices that Lisp and Common Lisp make may seem to be pretty peculiar. For instance, the calling conventions for some of the sequence functions are sort of weird sometimes. Some of the names are weird, like unwind protect, what the heck's that? But even so, I think that Lisp has really solid bones. And like an old house, I think it's worth preserving and using. So there we go. So I had to explain my joke. Sorry about that, but anyway. They always say that you should use humor in your talks. So one day, one day I was wasting time, looking at Twitter, and I ran across this, and it sort of tickles me. I think it's sort of funny. Years ago, I used to be involved in literary studies, right? So literature and criticism and all that. So I can't help but kind of put on my literary studies hat and look at this and say, well, what do they mean by this Lisp developer, rising from the grave, as an undead zombie? What's that supposed to represent? Is it that nowadays Lisp is experiencing some sort of renaissance, so that you have to get Lisp developers out of the ground and out of the graveyard in order to to meet the needs of the growing market? Or But I sort of think also that another way to look at it is that, at least in the Lisp developer case, it's it represents the language itself. So it's hard to keep Lisp down. You try to say, well, can it stay dead and buried in the ground where it kind of belongs? Maybe why does this shambling zombie horror keep rising from the tomb? And I think that there is, I'm sort of joking, and I don't really think that. I don't think Lisp belongs in the ground, so don't get hostile. But I really think that Lisp has some genius to it that hasn't been rendered obsolete yet. So I think that our little zombie there, recognize that you can't keep it down. It's too good of an idea. So just a few words about how Clozure CL came to be and about its background. We already mentioned that Lisp is 60 years old this year, which is sort of remarkable. I think that if you were to look at the Lisp of 1958 and the Common Lisp of today, you could see clearly that they are related, and that those same ideas that we had in 1958 are still present in the Lisp of today. By contrast, consider Fortran. Fortran's a little bit older than Lisp. The first Fortran compiler came out in about 1957, I believe. But if you looked at modern Fortran, what are they up to now? It's like, Fortran 90, Fortran, I don't know, do they have Fortran 2000, whatever. But if you looked at modern Fortran code and the Fortran code of 1957, they would be they would be almost nothing alike. So Lisp started out on a really good foot because the essential ideas have endured. Well, Lisp spawned many descendants. One particularly prominent descendant, of course, is Common Lisp, which first was specified by Steele's book in 1984. And around that same time, an intrepid band of hackers formed a little company called Coral Software. And Coral Common Lisp was their product that they managed to put together, and it came out in 1987. And if you can possibly believe it, they had a Common Lisp. It didn't have CLOS, so it was CLTL1. But if you can possibly believe it, it ran on a 1 megabyte Macintosh Plus. It has this incredibly weak hardware. So that was a real accomplishment. Hats off to those guys. I think they wrote a lot of 68,000 assembly code. And I remember talking to my colleague Gary Byers one time about current CCL. And I said, hey, look, we waste a lot of space sometimes in certain data representations, and if we made a little bit of effort, we could make things a lot smaller. And he said, listen, when I was working on old Coral Common Lisp and MCL after that, we worried about how many symbols were left over, maybe useless symbols in the heap image, because we didn't want the distribution to span extra floppies. He says, so I've done the space optimization game, got the t-shirt, not in a big rush to do it again. Well, anyway, after that, there was some stuff happened, and then Apple ended up acquiring Coral Software because Apple at the time was using Lisp and Smalltalk and other dynamic languages to do their research. So that happened. And then, as you might remember, Apple decided that the 68,000 series was too slow, so they decided, hey, we're going to switch to the PowerPC processor. So this caused a lot of big upheaval. And during that time, Apple decided that they didn't want to be in the Lisp vendor business anymore, so they transferred their Lisp to this company called Digitool. And at Digitool, they ported MCL to the PowerPC, and they released it as a product. That was around 1995 or so. And if anybody has ever had the chance to use MCL on a PowerPC Mac, really nice implementation. Really a good piece of work. A lot of clever design in there to get acceptable performance on fairly modest hardware. Well, then some stuff happened, and I'm not really sure exactly what it was because I wasn't there. But Gary Byers ended up working at JPL for Ron Garrett, who was known as the Ron God at the time. And Ron was interested in having Lisp on little embedded PowerPC thingies that were on robots or rovers or flight hardware. So in order to do that, they got a source license for MCL, and then Gary Byers worked and he ported it to this VxWorks operating system, which is a real-time operating system that runs on these little embedded guys. And since Linux PowerPC shared the same ABI, they kind of got that for free too. Now, obviously there wasn't going to be any Windows system or graphics or editor on this, so it was meant to run on these little embedded things. So it's all like non-graphical bits of MCL. Well, word about this got out somehow, and people were interested in it, and somehow permission was obtained from Digitool to redistribute the results of that port under an open source license, this LLGPL, which is the LGPL with this little Lisp specific preface. So that was in about 2001, and then that's how OpenMCL came to be. Since that time, there's been a lot of hacking and a lot of work on MCL. there was a software consultancy was formed called Clozure Associates. It's Clozure spelled with a Z, a Z. And sometimes there were Clozure clients who funded these improvements, and sometimes Clozure itself funded these improvements. But they took MCL and ported it to a bunch of processor architectures, ported it to a whole bunch of different operating systems, just a whole lot of stuff. Well, eventually MCL kind of ran out of gas, and I'm kind of going to skip over talking about that. A, because it's probably not that interesting and it's sort of sad, and B, we kind of got a little late start. But Alice Hartley, who had been carrying the MCL torch, almost single-handedly for many years, finally basically threw in the towel because it was just too hard to keep up with all of Apple's changes, right? So, Apple said, oh, well, this PowerPC, it hasn't really got what it takes anymore. We're going to use Intel chips now. So, MCL was looking at, well, what do we do? Do we retarget our compiler to the x86? What do we do about the user interface? We're using this old Carbon library, and now Apple hates that, and they want us to use this other thing. So what do we do? So I think they just decided they just couldn't keep up. Apple just kind of got them by changing so much. Well, anyway, we had OpenMCL, which was the thing that was originally done at JPL. Then we had MCL, which was becoming open source. So I think, well, we can't have this because it's going to cause tons of confusion. So to make it less confusing, we'll call OpenMCL Clozure CL, right? Because nobody uses the name Clozure for anything, do they? Well. And so how many different ways can you possibly spell Clozure? So, Clozure with an S, Clozure with a Z, and, Rich Hickey's Clozure with the J thing, and how are you going to spell the next Clozure thing? I don't know. It's kind of crazy. And I remember being at a conference, I think it might have been in about 2008, and Rich Hickey was there, and I went up to him and I said, hey, man, Clozure CL with a Z was around a lot longer than your Lisp. You ought to change your name. And he didn't really want to. Well, anyway, let me talk a little bit about where Clozure CL stands today. It supports a couple of processor architectures. Right now, it's the x86, 64 and 32-bit versions. It supports the 32-bit ARM, and we kind of support for PowerPC kind of fell away because the hardware that we had to keep the port going just sort of died after a while. And although I really liked having the port around because it kept us honest in multiple ways, it was just too much of a pain. And it runs on a bunch of operating systems here. It's old. It's one of these old Lisps. If you look in the source code sometimes, you'll see comments like this, so from slisp reader.2.lisp and not touched in 20 years. So here's parse integer, from the reader. And so along with other implementations, Clozure CL borrows a lot of code from SpiceLisp. That's what slisp is, SpiceLisp. And SpiceLisp was the ancestor of CMU Common Lisp. Well, anyway, and if you look at the fancy loop macro or the implementation of the pretty printer or of the format function, and you compare that to code in, say, CMU CL, you can see there's a lot of commonality there. So, the old Lisp guys, borrowed a lot of code from SpiceLisp. So, hey, let's pour it out for SpiceLisp. Thank you, SpiceLisp. Another benefit of being old is that when you're making a Common Lisp implementation, there are just a ton of problems, a ton of subproblems that you have to solve. If I had to make a Common Lisp implementation from scratch, I don't know what I would do. I'd be at it for a pretty long time. There's things like printing and reading floating point numbers, which are an interesting problem in themselves. There's papers about this problem. Implementing this in a Common Lisp from scratch would be kind of a pain. So it's nice to have the old Lisp behind you to do that. There's other things that you need, and even simple things like random number generation. How hard can it be? But there's all sorts of trade-offs in that you need to be looked at. Do you want it to have good statistical properties? Do you not care about that? Do you just want it to be really fast? Do you want to use it for cryptography? All sorts of different things. Anyway, one thing that I've always sort of wondered and always had a hard time learning, and I don't know if I could have done anything better to know this, is who uses the Lisp? right? We distribute it on an FTP server or via a web server, and people just download it, and we've got a version of it on the Mac App Store, and it's like, well, I don't know who gets it. Apple doesn't tell you. So just for jollies, a couple weeks ago, I had this survey that I put out on Twitter and the mailing list and the Freenode channels, just to see who might pipe up and tell me tell me what they use to run CCL on. And since the survey kind of confirmed my preconceived expectations, I put a lot of stock into it, so I believe that it must be true since it confirmed what I already thought. And here is just sort of to give you an idea, these of the respondents, most used it on Linux and on the Mac. And the only thing that really surprised me was quite a number of people ran the Lisp on Windows. So that's great. I'm glad it's working for you. The Windows port is probably the weakest port because the CCL hackers don't really use Windows as an everyday system. So that's sort of unfortunate. So I think Windows is kind of getting the shaft here. It's in some sense the CCL red-headed stepchild. But that's just how it is. But it seems to work pretty well, modulo a couple of annoying bugs, like sometimes when you try to quit the Lisp, it hangs, but you never quit the Lisp, right? Why quit Lisp? And as far as processor architectures go, as you would expect, 64-bit x86, by far the most commonly used processor architecture. There's a couple of people, quarter of the respondents use the ARM, and then some still holdouts on 32-bit x86. The reason I asked that question is because I was thinking about, given 32-bit x86, the axe and dropping support for it. So, but as it's still working, I don't think it makes sense to just shoot it in the head, so to speak. But on the other hand, since the backends for the x86 platforms are kind of combined, it probably is going to make sense to separate those, and whether the work involved in doing that is going to be worthwhile, I don't know, because you don't want continued evolution of the 64-bit backend to be hindered by the legacy 32-bit backend, and I like the legacy 32-bit backend because that's I wrote it. I think CCL has a number of different constituencies, and their preferences and their requirements don't necessarily align. I think there's a certain constituency that uses CCL sort of in this batch mode, where they'll run this big job and then they'll submit it to this supercomputer clustery thing, and then they'll crank on stuff. So there's a sort of this batch style processing, and then I think there's some just normal hackers who use it with Emacs and Slime and in the way you would expect, and then I think there's a substantial and interesting contingent who are interested in Lisp, but they're not too interested in investing time in learning Emacs and Slime. I know, some people are shocked, but it's true. And for one of those reasons is why I made the Mac App Store version of CCL, where we had this kind of IDE that kind of grew from just sort of example code into something much more than that now. But there are people, so those, I think maybe MCL refugees or people who would have used MCL, would like something like this. Briefly, I'm going to just talk about some technologies in CCL. I've kind of avoided, I hope not incorrectly, getting deep into the technical weeds about any particular thing. I just kind of wanted to give you an overview of some of the stuff. Normally I get a big charge out of talking about all these little bits and data representation and all this trickery, but I thought maybe for this talk that wouldn't be so appropriate. More with the cartoon thing. One of CCL's hallmark features has always been that its compiler was pretty speedy, and that's nice. If you've got a big project in, say, Xcode, and you're trying to compile Apple Swift, maybe the language is Swift, or maybe something else good about it is Swift. It's Swift in some other ways, but it's not too Swift when it comes to compiling. Or so. And I think that's really a surprisingly nice feature. With Lisp, it's a little maybe not so important, maybe, because you can compile things incrementally, and you save your image and so forth. You don't maybe so often build a whole system, but I guess that's what I want to say about it. And the compiler doesn't have, a lot of brains. It doesn't work all that hard, but its goal is to produce something reasonable pretty quickly. And as often as not, it's able to produce something, halfway decent, even good, pretty quickly. One historical weakness has always been, if you're a number cruncher, CCL tends to be kind of bad about that. It would const double floats like crazy and just, be a big mess. But you can make some effort with some declarations, and you can get some floating point code that is halfway decent, if not good. So the compiler definitely could stand to work a little harder, and it would still be fast. One nice thing about it is you can build the Lisp in under a minute. On my iMac at home, it takes 30 seconds to rebuild the whole Lisp from scratch. And that's nice. So I guess in some ways CCL is optimized for CCL hackers. So the CCL hackers are often rebuilding the Lisp. So being able to do that in 30 seconds is pretty nice. And I think this happens with all sorts of software. When new people come and they start using CCL in a new software system, new issues arise, new bugs turn up, including performance bugs. And more often than not, those performance bugs tend to be not endemic so much as nobody ever really complained about it before. And we can often resolve those performance bugs without too much trouble. But it is true that CCL's goal is to produce something reasonable quickly. It doesn't do anything heroic. We have native threads in CCL. This isn't even very interesting. I mean, this is like table stakes for a general purpose, Lisp implementation. It has a couple of some funny things happen because Lisp wasn't designed with multiple threads in mind. So for instance, one thing is with hash tables, what happens when you're accessing a hash table from multiple threads, right? Do you have to do some synchronization somehow or what? And in CCL, we have hash tables happen to be thread safe, and they use this fancy pants lock-free algorithm that does all this complicated stuff and tends to work pretty well for read mostly hash tables. There's keyword arguments to make different kinds of hash tables that might work better in different circumstances. What happens when you try to write to a stream from multiple threads? Something bad, maybe? So one sort of weird thing that CCL does is when you make a stream, it only works from the thread that you made it in by default. And this is totally a performance hack. It's semantically really gross, but the performance was such that they decided to do this. And again, there's keyword arguments to the open function where you can make streams that will work across threads, but then locking becomes involved and performance becomes an issue. And then what do you do with special variables with threads? We've had papers about this before, and CCL just uses the pretty much standard scheme of these thread local shallow bindings. So there's a small number of instructions that you have to execute to get whatever the current special binding is for the thread in question. Anyway, sorry if I'm getting down into the little technical details that are boring. The other thing about CCL is it's got this sort of interesting garbage collector. I don't claim that any of it is really novel. It's all in the literature. But the way CCL works is that it manages one contiguous range of address space, this single space. And when CCL starts up, it reserves this large address space from the operating system, like 512 gigabytes large, so I'm talking large. And then it commits a certain amount of pages to be used by the Lisp. And the old objects, they get allocated on the left, and as allocation takes place, the objects go to the right. And when it's time to do some garbage collection, the garbage collector scans the heap, marks all the live objects, and then it squishes them all together. So it just compacts them together. So all the objects on the right get scooted over towards the objects on the left and squeeze out all the little gaps. So the heap is temporally ordered. So the old objects are always on the left and the young objects are always on the right. We do some tricks to exploit what's called the generational hypothesis. You might have heard of this. The generational hypothesis is most objects die young, right? That's basically what it is. So what we do then is we have some generations here, and we treat those just as though they were the big heap. So we treat it as this was the base of the heap, right? So you start GCing from here, you mark, and you squish. But you only use this teeny little fraction of the heap, and that's really fast. So a millisecond or so, and boom, you're done. And there are some complications with that, as you may know. You have to keep track of the case when old objects are mutated to have references to new objects, and we use a software write barrier to do that. But it works out pretty well. So there it is. I've heard that the .NET GC is this Mark compact type. I don't know. There's a guy named Patrick Dussoud who used to be a Lisp guy at TI, and he ended up working on that at Microsoft. So maybe that's where he got the idea. Some implications of this GC are that Lisp, objects move around on you. So since objects move around on you, you can't really pass Lisp objects to foreign code, to C code, because C doesn't expect that you're going to move some object out from under it, and it's going to get very unhappy. So whenever you have to operate on Lisp data from foreign code, you're with very few exceptions, you're looking at copying. And another limitation is that the GC runs single-threaded. That's just a question of difficult engineering to, either you can make the marking and the collection, you can maybe use multiple threads to do that, or if you're really ambitious, you can say, well, let's invent a collector where the mutator threads and the collector threads can run at the same time. And that's doable, but it takes some work. The final CCL feature that I'd like to talk about is that it has this sort of cool foreign function interface to call C code. Now I know that probably a lot of you prefer to use a library like CFFI to handle your foreign function needs, but I think CCL's native FFI has a couple of cool features that I'd just like to mention here. So if you know a C function by name, you can call it using this sort of middle level external call function. So basically you can just DLSIM some symbol and you call it, you're specifying the return type in this case. There's also some notation for describing and accessing some foreign data. So what I do here is there's this form called rletz, and rlet stands for recordlet. And again, this is sort of like the Macintosh heritage of CCL that shows through, because back in the Macintosh day, you used to use Pascal to program the applications, and Pascal would call its aggregates, it didn't call them structures, it called them records. So sometimes you'll see in CCL there'll be something like, make record, or rlet for recordlet. So rletz, just we allocate an array of 10 double floats on the stack, on the C stack, zero those guys. We use this PA-ref operator to monkey with, to initialize some of our foreign data, and then we can just use external call to call this BLAS routine to perform this operation. And notice that we have to specify the types of the foreign arguments so that the foreign function interface code can do the appropriate marshalling and unmarshalling of and conversion of the types. So that's sort of a drag. So we use this thing called an interface translator, which parses the C header file. So here's an example from curl.h. So here's this declaration from curl.h that is for this function curl global init. And then this program, it's been called FFI-gen, and it's based on a patched GCC, or nowadays we're working on a new one that's based on libclang. And I want to give a shout out here to a volunteer contributor. His name's Bo Yao, and he worked on figuring out how libclang works. So thanks to him. If you're out there, thank you very much. And it produces this S expression-based representation of the C declaration. So with that in hand, there's Lisp code that then reads that and writes this little database that tells the Lisp, hey, this is the sort of types and sizes that these foreign function needs. And in that case, we can use this little convenient reader macro sharp underbar to call this foreign code. So we say sharp under curl global init, and then we can also look up the names of the constants. So there's that header constant from C that we can refer to from Lisp. So that is sort of convenient and cool. Maybe you don't care that much. Maybe you say, foreign code. Who wants foreign code? You want code in Common Lisp, and that's certainly true. I mean, if you can, have your code in Common Lisp, you're a lot better off usually. But sometimes you just have to. A couple of related projects. We use a version of Dietz's ANSI test suite, which we made a copy of, and we've since added CCL-specific tests to. That's on GitHub. We've got this documentation system that's sort of this homebrew thing. It's called CCL doc. It actually runs on SBCL thanks to some patches that people have sent in. And the interesting thing about this is the manual for CCL, I think it used to be written in TechInfo. Okay? Nobody liked TechInfo. So somebody volunteered and said, hey, TechInfo, that really blows. Let's use something better. So they picked DocBook. Well, DocBook's not better than TechInfo. It's horrible. And even though DocBook might be really flexible and you can do all sorts of things with it, writing documentation totally stinks. And the CCL hackers didn't do it. So we'd add new features to CCL or do things and say, we really ought to add this to the manual, but that would involve editing DocBook. So let's just not. So we went round and round about this and said, well, maybe we should just use LaTeX. Oh, no, LaTeX is almost as horrible as DocBook. And then we said, well, how about this program Lix? Lix is all right. That produces pretty good output, and that didn't get much traction. So Gail Zacharias of Clozure finally got sick and tired of all of us whining and refusing to do anything. So she cooked up this homebrew documentation system called CCL Doc. And the nice thing about CCL Doc is it's not too horrible. It uses this S-expression-based representation of the document, and writing renderers for it is pretty easy. So there's all these. All you have to do is, you've got this data structure in memory, and then you just follow this little protocol, and then you can write an HTML renderer for it pretty easy, a tech renderer for it pretty easy, a markdown renderer for it, whatever. So that's sort of a neat thing. And like I said, we're working on this updated FFI gen based on libclang, because GCC 4.0, that's pretty old, and it's hard to maintain a set of patches, for something that your system needs. And the nice thing about libclang is they say libclang is stable, because otherwise, if you've ever worked with LLVM, they break things all over the place, and every release changes, and you don't want to get on that treadmill if you can avoid it. So that's why libclang comes into play. So some people have wondered, hey, what's the future of CCL? And one item is, well, we kind of just need to keep up. Well, for instance, an example of keeping up, the upcoming FreeBSD 12 has some ABI breakage in it. It changes the ABI. For instance, the size of struct stat changes because they decided, 32-bit quantity, that's too small for inode numbers. We need to have a 64-bit quantity for inode numbers. So now, we've got that database, right, that I talked to you about foreign function interface. So when we want to do sharp underbar stat from CCL, it thinks that, here's the layout of struct stat. Well, in the FreeBSD 12, it's different. So you have to, make those modifications and just keep up with that sort of stuff. One other thing that we'd like to do is, we recognize that, the compiler sort of, hasn't got a lot of brains. So there was this, there's this experimental new register allocator that we've been working on that's sort of opt-in in the development branch, and that tries a lot harder to keep, values in registers rather than treating the stack frame locations as the canonical locations for variables. We're probably going to need to do a port to ARM64 pretty soon, 64-bit ARM. I like the Macintosh platform, so that's an important platform for me, and it won't surprise me at all if Apple comes out with an ARM64-based MacBook in the next couple of years, and I'd like to have CCL there. And there's, just the usual, bugs that come up. One thing that I think would be really great is a modern macOS IDE. I guess it could be on another system too, but like I say, I like the Macintosh, even though Apple is kind of a slave driver. They really make you keep up, and that's sort of hard. So I've said for years that I think Emacs and Slime are kind of a local optimum when it comes to Lisp IDEs. And I'm always sort of nonplussed when I hear people who are really enthusiastic and they say, oh, well, Emacs and Slime, that's the most wonderful IDE ever invented by man. I say, well, it's nice, I guess, but I think you're overstating the case. So anyway. I mean, I use Emacs, and I'm sort of a Slime caveman myself, so don't get me wrong, but I think that there's opportunities to do better. So anyway, there's that. How am I doing here? Sorry. All right. One thing that I've always sort of been bothered by, although maybe it's never bothered anybody else, is the fact that the Lisp is named Clozure CL. I've always worried that people might have the impression that it's Clozure Associates, the consulting company. I've always worried that they think that it's their product, or that they own it, or that it's their private playground somehow, and that they let you play in it, but you're not, they don't really want you messing around with it. And that's really never been the case. Even in the days when we ran our own Subversion server and used Trap, we were more than happy to give out commit access to anybody who demonstrated the least amount of competence. All you have to do is, do you know up from down? Okay, go ahead. But we've got really very few takers. one thing that we were able to do, and that I was able to do while I was at Clozure, is they were able to obtain the copyright for the sources from Digitool before Digitool disappeared. And having done that, I suggested that we change the license of CCL from the LLGPL, which some people find a little bit maybe hard to understand or a little bit peculiar or cause some worry, to Apache 2. So I thought Apache 2 was pretty easy to understand. It made it clear that contributions you made to the CCL weren't going to be exploited against your, you weren't going to be working for free. Nobody was going to exploit you. Nobody was going to, take your changes and give you the shaft in any way whatsoever. So I thought that would, I thought that might be useful. As far as who is hacking on CCL, you might know or you might not that Gary Byers, who has worked on CCL since the old days, recently had to retire for health reasons. And this really sucks because he is a great programmer, a great hacker, and if ever there was a 10x hacker, have you ever heard the term 10x hacker? There's some programmers who are just 10 times better than just your average programmer, right? Because they're the good ones, and you want those people. And if ever there was a 10x programmer, it's Gary. So not having him in the project, is a real loss. That is a total drag. So you're stuck. So the project is, left with me, and I'm not as good a hacker as Gary. That's for sure. So if he's Batman, at best, I'm going to be Robin. You can help CCL. If you can. It's on GitHub now. I moved it to GitHub from Subversion. I thought maybe that I could benefit from GitHub's network effects that way, and maybe make it easier for people to contribute. There's a channel on Freenode that I hang out on. You're welcome to come to. You're welcome to participate on the mailing list. And if you want to just do cool stuff with CCL, that helps too. Again, I was wasting time on Twitter one day, as I sometimes do. And when the news broke that Gary was going to have to retire because of his health, I was at a full-time job where I was writing Clozure with a J, of all things, and while I was there, that was taking up a lot of my energy, right? So you're working full-time, you're working on this other dialect, and I was really worried because perhaps neurotically, I feel like I have a responsibility not only to Clozure CL, which I love, a software system which I really like, and I felt that I had a responsibility to its users. So when I ran across this tweet, that sort of, I said, yeah, I know how that feels. I'm going to have to call this guy up and find out who his therapist is, because I'm going to have to, maybe I'm going to have to go to him sometime. One nice thing about Clozure CL is that you can get help for it. If you're using it in your business, Clozure CL, Clozure Associates is the name of the company. Clozure CL is the name of the Lisp. Don't call the Lisp Clozure or Clozure Lisp, okay? It's Clozure Common Lisp. And I said that 5 years ago, by the way, so that's just a reminder. So Clozure can offer paid support for it, or you can hire me to do whatever you want to with Clozure CL, so you can get help. And for some reason, I felt that I really just needed to say this. You know what I mean? I like Common Lisp and I like Clozure CL, and so many times I've been at Lisp conferences and there's so much hand wringing, and we have these panels and say, oh, what are we going to do about Lisp? It's dying, it's all weird and nobody likes it. And what the heck, let's have a little optimism here. Common Lisp is a great programming language. Clozure Common Lisp is great implementation. So the standard is old. Yes, it is old. It's probably never going to be revised, but it still provides an awesome baseline level of functionality that you can rely on and that works across multiple implementations. And we have multiple Common Lisp implementations. CL2? I don't know. There is that, but I don't know if that's ever going to result in an update to the. I don't know. So even for a programming language like Common Lisp, which is relatively obscure, we must admit, there are multiple implementations to choose from. From specialized to general purpose. There's got to be 8 easy, right? 8 a dozen. I don't know. That's sort of amazing. And out of all these implementations, I happen to like Clozure CL. Maybe you like some other implementation, but I think we can still be friends. This is an excerpt from Peter Norvig's book, Paradigms of AI Programming, and he gave a talk at Lisp NYC. Yeah, you were there. And I was watching that talk, and he said this, and he says, you know what? You know, here are all these features that Lisp has, and all these features, except for the underline features, have been adopted by other languages. So, even though Lisp is still, hasn't taken over the world yet, even so, he was saying that, since its ideas had been adopted by other programming languages, Lisp had ultimately won in some way. And I was watching that, and I was sort of bemused, right? I said, that's sort of strange. That doesn't really seem right to me. And especially given the importance of some of the features that have been left out. For instance, the whole Lisp macro situation is extremely powerful, and that's the reason a lot of people, or at least the reason some people, use Lisp, because they exploit that. And I just want to remind you that there's a programming language you can use that has all these features. Yeah, it's called Common Lisp. Yeah.
So Peter actually made the point that he actually implemented before and after methods using decorators in Python. And what he said was that we're still doing Lisp, we just call it Python. And there's actually a lot of truth to that.
That may be. One other thing that I like about Lisp very much is that interactivity is kind of built into the design of the language, right? The language assumes that you're going to be using it in an interactive way, right? So there's these standardized functions and macros like trace and break, and they only make sense if you're using the language in an interactive way. And this is just sort of implied. And I think that the people who worked on the standard, they said, well, yeah, duh, of course you're going to use it in an interactive way. And you even have sort of crazy things like this update instances for redefined class method. And it's, well, of course you're going to create a whole bunch of CLOS instances, and of course they're going to be floating around in your image, and of course you're going to want to change them, and of course you're going to want to be able to update them. And so that just sort of attitude I think is really awesome, and I totally like that. And for me, when I interact with Lisp, when I'm at the top level and I'm typing in Lisp and I'm doing things and I'm recompiling my functions, I really feel like I'm talking to this spirit that's inside the computer. I'm having this conversation, and that was one of the coolest things about early micros, right? You turned on your Atari 800 or whatever, and being ready, and you could type stuff. It's like, okay, plot X, Y, and you could do all sorts of stuff. You weren't having to compile anything. You just did stuff. I think that's so wonderful. You talk to the spirit inside the computer. And for me, that works for me for some reason. So, maybe there's some problem that I'm trying to solve, and I interact with the Lisp, incrementally, and I do stuff. My one-time colleague, Michael Evans, he talked about this. He says, you teach the computer how to do stuff. And that just works for me. I don't know why, that just works for me. It's been said, there's sort of a joke running around that Lisp is a great programming language to use when you don't know what you're doing, right? And since I hardly ever know what I'm doing, Lisp is a great programming language for me. On the other hand, there's something to be said for knowing how to solve the problem. So sometimes it's easy to get it's easy to be tempted, to peck away and and to mess around with stuff. When really, you might want to think about what you're doing a little while first. That's kind of a good idea. So, anyway, so that is. So, what do we say then to the notion that we're stuck in the past, right? This is Edna Mode. She's from the film The Incredibles, and she, Mr. Incredible had come to visit her because he'd torn a hole in his supersuit, and she says, "Oh, Edna, fix my supersuit." Says, "Oh, this is trash. I don't want to do this anymore." So what do we say to that? Here's a quote from Hamming that I like, and the essence of the quotation is that Newton would say, I stood on the shoulders of giants, and that's what enabled me to see a little bit farther, when it comes to inventing the calculus and so forth. And Hamming's point is that too often in the computing field, we re-implement stuff, and we don't build on each other's discoveries too much. We stand on each other's toes. And I think there's some truth to that, and I don't think anybody really escapes from that. Let's laugh at the JavaScript programmers, okay? That's always fun. So here's this comic called Commit Strip, which I like to waste time on. And here's our front end, here's our intrepid front end JavaScript hacker, and she's wondering, well, do I pick one JavaScript framework and master it, or do I, pick a new one every week just so I can keep up to date, right? Because there's so many. So haha, we all laugh. Let's all laugh JavaScript. Haha, you JavaScript programmers, you're all so silly. But this is not a technical problem. This is a social problem. And back in the time before Common Lisp was standardized, ARPA called a meeting one time of all the Lisp hackers that it was supporting, all the research environments it was supporting, and it was getting concerned about this proliferation of Lisp dialects. And they said, hey, what about this? It looks like you're sort of, you're kind of in a state of chaos. And I think it was Scott Fallman who came out and said, look, the Mac Lisp community, which was the MIT Lisp, it didn't have anything to do with the Macintosh. The Mac Lisp community is not in a state of chaos at all. We're 4 well-defined groups going in 4 well-defined directions. Same thing. Sometimes people ask me what I do, and I try to, what I do for work, right? And what I try to do is I try to get away with something simple. I say, oh, well, I write software, and hardly anybody is satisfied with that. So then it's pretty hard to say, oh yes, I work on an implementation and runtime system of a compiler for the programming language Common Lisp, and then at which point they sort of just back away. So what I've taken to saying is that I build tools. Programmers need tools to build their software, and I help build tools for those programmers. So just like artists need brushes and canvas and paint, and sculptors need chisels and stone and hammers, I help make those things. So, and here's another quotation from Knuth where he talks about how liking your tools is such an important component of enjoying your work, and I think this is really true. And even if there's another proverb called it's a poor workman who blames his tools. Have you ever heard of that? Well, I think my response to that would be, if you've got crappy tools, you need to use those tools to make some good tools that you like. So finally, one of the coolest things about working on a tool, about working on Clozure CL, is seeing what people have done with it. That really is awesome to see what people do. This is a screenshot from the program Opus Modus, which I helped work on. I made the user interface, and it's like what it really is. It's a Lisp development environment specialized for musicians. Is pretty much what it is. But there's a whole raft of functions that do all sorts of operation on music. You can process notes and generate stuff in weird ways, and there's a couple screenshots from that. And I'm very, very pleased to have worked on that. I'm very proud of that. And so visit their website and if you want to. Another test. It's always nice to get a testimonial. There's some people who use CCL to run the software called ACL2. Has anybody heard of ACL2? It's a theorem proving software, and because the ACL2 guys and the CCL2 guys talk to each other, we've been able to benefit from each other's expertise. So we were able in CCL to add a feature called static consts. So what a static const is you can const up something, you make a const cell, and it doesn't ever change its address. And this is really helpful for them because ACL2 stands for applicative Common Lisp. So it's all purely functional. So when they do that, that really helped them. That really made their software perform a lot better. So that's in the sort of hardware verification space. All right, well, let me wrap up here. Again, years ago, I used to work in the theater. And one of my jobs that I had was I was in a video that was going to be shown at a sales conference for rice salesmen, of all people. Rice, the grain. Anyway, in the video, I was a swashbuckling swordsman, and I represented the forces of mediocrity. And in the video, we were doing this sword fight, and I was ultimately vanquished by another swordsman who represented some virtue, excellence or whatever it was, diligence. And they showed this video to the rice salesmen in an attempt to, get them to, think about how important and great it would be if they would meet their sales quotas for selling rice. I guess maybe it worked. I wish that I had a fancy hat with feathers and a sword that I could use to vanquish the Lisp naysayers. You know what I mean? But I left all that stuff at home. But what I can say is I really like Common Lisp. I really like Lisp a lot. And I want to tell you that it's okay to like Lisp and that it's okay to write programs in Common Lisp. And I'm really looking forward here in the rest of the symposium, hearing about what you've done with Lisp and what you're doing now with Lisp and what you're going to do with Lisp in the future. And I'm interested to hear about what your dreams are for doing new stuff with Lisp, because Lisp is great. So thanks very much. I appreciate your attention. Let's go out there and hack some more Lisp. Thanks. I think that's probably true. I think that the reason Lisp is so great is that it has all of those features. They're together in one place, and somehow they work together to...
There's also not one language that has all of them except the two at the bottom.
Yeah.
So Python has all of them except for what can see.
Except for the uniform syntax, yeah. I don't know, I'm not much of a... I'm a caveman Python hacker, so... Yes.
IBM gives you free access to PowerPC 64 machines, if you ask them nicely, because they want to promote the platform.
Oh, yeah.
Virtual machine somewhere, and you can even buy not really cheap hardware, but a machine with 140 cores and 128 gigabytes of RAM was about 3,000 euros a few years ago when they promoted it heavily.
Yeah, that would be fun to do. Yes.
No, it doesn't.
Je vous écoute. Yeah.
One more remark from me. There was a Facebook scandal recently, the Cambridge Analytica one, and I have read an article that described the RSS protocol, the really simple syndication for news. It described that RSS was alive back in the day, then it was dead, and perhaps now it is undead. In a way. And the site that we showed with these programmers shown as something surprising from the dead kind of reminded me of the same thing.
Oh, there you go. Thanks a lot, everybody.